Hi, good morning. This video is going to introduce lab number 8, which is conservation of momentum. And we are going to use for that Beyond Lab Z. I will share with you my data and how the lab is going to be done. Then this is the instructions here. Let me check one thing. Student view, if you're it's locked yet. Okay, I need to go and find the lab here. Okay, and you're going to go to the page. It is okay. I need to exit the student view, and then here conservation of momentum. Okay, and this is the updated lab. You need to stick to the numbers that I have here, okay, because my numbers are different. Okay, then I want you to stick to the numbers that I have here. I will show you one of the attempts and how to graph and share with you my graph, my Excel sheet. If this is a formal lab report and you need to submit 2 files, one of them is the Excel file and the other one is the formal lab report. Of course, today we are going to have collisions, and in all these collisions there is no external forces, and therefore we are going to have the I will say momentum is conserved. I'm gonna go to Beyond Lab Z just to show you where we are going to access the lab. Then okay, go to the desktop, open the virtual physics. Oh, it did open it right away. Okay, let me get rid of this because I want to show you how I will go directly to open. Okay, and then under forces and interactions, you're going to find the momentum conservation of momentum. Okay. Now the lab is gonna be this way. Now in order to change the velocities, you're gonna have the parameters here. You are going to go to objects. This is ball number 1. You can see its mass, and here also how to change the mass. This is 10, and okay, this one for you is gonna be 18. Then you're gonna just click on 18. I wanna keep, for my attempt, I wanna keep it 10. Okay, if you wanna change ball 2, you're gonna go ball 2 and also change it. Okay, then here I'm gonna say ball 2 is 10 and ball 1 is 10 as well, but you can see that ball 1 is going to the right, then it is positive 10, and 2 is going to the left, then it is negative 10. Here it will not show you the direction. Now, in order to keep my data, I need to, every time, remember, you need to reset, but for me, like this is my first one. I'm gonna record, I'm gonna start, they're gonna hit each other, and then I'm gonna pause. Okay, then this is my first attempt. If I will go to the lab, I will find there is a data that I'm gonna copy. All right, and I did go to my Excel. Now here the tabs, you're gonna have them trail 1, trail 2, trail 3 as outlined in the the instructions. this part here is going to show in my data. How did I find? Of course, I know that the masses, I set them equal masses, equal velocities, and that elastic. Yeah, one thing that I want maybe to share with you, and I did not do that, is here, can you see elasticity? We're going to set it to 1. And if we want to have it completely inelastic, we're going to set it to 0. Then this is really the elasticity thing. Okay, let's go back here. Now, I did use 10 and negative 10, 10 and negative 10 for this is the forces, the velocities before. And then after the collision, this was negative 10 and this is 10. How can I get this from the data? Look here. This is all these here. The first, they're going to show you the velocity of ball 1 before, and then when it will change, this is going to be the negative 10. Pay attention, sometimes it will recoil and then it's going to give you a third velocity. Don't consider it. Then this is the first one. This is the velocity before, the positive, and the negative is after. For for ball 2, okay, I have it here. Okay, is like it should show in the same one. Okay, this is negative 10 and then it will change to 10. Okay. Okay, now these here, you don't have to have them in your formal lab report. Just you are going to transfer this. This is going to be in your the data for you know, the first attempt. Now here I will calculate the momentum of the first ball before collision. Then I'm gonna say equals, I have the mass as 10 and multiplied by the velocity before. Then this is really the momentum for ball 1 before. After, you're gonna come here and you're gonna say it's gonna be 10 times negative 10. All right, and here for ball number 2, this is the mass of ball number 2 and this is its initial velocity. And for here, this is going to be the second ball, but this is its final velocity. All right, and then here I'm gonna add the total is gonna be this number plus this number. And also for sorry, let me, I want to have the total for sorry, this is not my total. I want to have the total for, oh yeah, I'm sorry, yeah, this is like the initial for both. And I'm gonna say this is okay, and here I'm gonna say this is this plus this, and here equal this plus this. Okay, and remember here the total is gonna be 0, 0. This is trial number 1, equal masses, then both are 10, 10, equal velocities, they have equal magnitudes of the velocities, and it is elastic. Now for the second one, it's gonna be elastic in equal masses and in equal velocities. Okay, therefore I put 15 for this one and 5 for this one. I want one of them to be maybe, like in your case, 18 and the other one is 0, and then I will measure the final. look here, ball number 1, this is its initial and this is its final. That one, it is after it hit the wall and recoil, forget about it. Okay, for ball number 2, this is the first velocity and this is the second velocity. Okay, which is this one. Okay. Then I have recorded the values. Again, I will do the same, and look here, my total is gonna be the same. Now I will also go to trial 3, in equal masses, equal velocities, elastic. Then here I have the masses different, velocities are really the same, and I'm gonna do the same thing. And then I will also, this is gonna be under your calculation. Okay, number 4 is gonna be in equal masses, in equal velocities, and elastic, and I'm gonna do the same thing. For attempt number 4, I want you to create a chart. That chart is gonna show the momentum, you know, before and after. And just here, let me show you how you're gonna graph this. Okay, and then here I will have ball number 1. I'm gonna get its momentum before and after. Okay, this is really here, and I will say insert, and then I'm gonna say dot, and then I want to be sure that I have the time as my X. Then I'm gonna say select data. I will say ball 1 momentum, and for my values for the time, all right, and then I will say add ball 2 momentum, and that is equal have it until 16. I think, yes, that's correct. Oh no, the X is gonna be the time again. Okay, and for the Y, I'm gonna get its momentum. Okay, till 16. It's not all. I think this is no, this is 17. Make it 16 to get the same number of, and then this is my graph. You're gonna transfer also the graph, move it to a new chart, and then you say trial 4 graph. And then you are going to come here, you're gonna say momentum and the units, the chart of the title of the chart, and also you're gonna also label this axis with the unit. Okay, then this is required only for number 4. Number 5 is gonna be inelastic, equal mass in equal velocities, and in equal masses in equal velocities, and the last one is gonna be inelastic, in equal mass in equal velocities, and inelastic. Let me show you how really the inelastic is gonna show. I need to reset. Sorry. Parameters. I'm gonna put this elastic, and let me have the equal masses. Okay, I'm gonna keep the masses equal, and I'm gonna make one of them, let's say 15, the velocity, and the other one, ball 2, I'm gonna keep it 10. One of them is gonna be faster than the other, so that it will catch with it. Okay, then here recording start, they're gonna come together and move as one unit. Now when I go to my data here, I will copy, oh no, not this one, I want to copy this one, the second one, and then here, like just a weapon, I want to add that one here. Okay, you can see here that it was moving 15, and that one was moving -10, and then we have the velocities for both. And that one is when I have, for example, here I have equal masses and equal velocities completely inelastic. Completely inelastic means they are going to stick together. Under your results section, I want you to summarize. Then you are going to create let me get something like okay, I will maybe add something here, like just to show you an example. Like, of course, this is gonna be, you are going to be the one who's gonna work on these. Oh, let me see if I can add. Yes. Okay, then here you are going to say trial number, and then you're gonna say 1, you have 6 of them, 2, 3, 4. You're gonna say here elastic, inelastic, velocities, okay, I prefer also maybe, okay, let's do this here. You're gonna say not elastic, not okay, you're gonna copy here, you might say elastic equal masses equal, for example, something like this, equal velocities. Okay, then you are going to put the labels, and then okay, and here you're going to put velocities. Okay, not velocities, here you're gonna put moment pi, you're gonna say pi just for the total and the unit, of course. You're gonna put p final. Okay, of course, make these subscripts. And here percent difference. You're gonna do this for all. This is gonna be under your results section, and of course you are going to conclude something about the lab. Okay, thank you and have a great day, and please contact me for any questions.